Let's try some easy values of n. We'll start with n equals 1, so that means f of 1 is this sum. When k is in the interval between 1 and 9, the floor of this logarithm is 0. When k is between 10 and 99, the floor of the log is 1. And then when k is equal to 100, this log is 2. We'll take the sum of these to find f of 1. We have 9 values of 0, and then for k between 99 and 10, we contribute 1, and then we have 2 more points when k is equal to 100. This means f of 1 is the sum of these, or 92. We'll try n equals 10, so this is f of 10, and when k is between 1 and 9, the floor of our log is 1, k between 10 and 99. Each of these terms contributes 2, and when k is equal to 100, the log is 3. So we'll calculate f of 10. We have 9 terms that contribute 1, 90 terms worth 2, and then the last term is 3. So f of 10 is 192. Now we'll continue with n equals 100. And with these same cutoffs, our logarithms all increase by 1 again. So f of 100 is 292, and we're getting close to 300. Let's see what happens as we increase n. When n is equal to 1, f of n is going to be 0 in this interval. It's going to be 1 here in this middle section, and then at k equals 100, we're going to get a floor of 2. We'll compare this to n equals 10. Here in this interval again, we have a 1, and then from 10 to 99, we have a 2, and then our last value is 3. And then when n is equal to 100, we get 2 in this interval between 1 and 9, 3 here in the center, and then our last value is 4. To get f of n equal to 300, I'd like to replace some of these 2's on the left-hand side with a few more 4's on the right-hand side. So I'd like to center this region here, values of k that generate a 3. I'd like to move it closer to the center, so it's closer to being symmetric around k is equal to 50. And I'd like this corresponding value of n times k to be right between 1,000 and 10,000. So I'm just going to say that we want it to be approximately the average of our lower and upper bounds when k is equal to 50. So we'll substitute and ballpark this for n. This gives us a value of n is equal to 110. So let's calculate f of 110 and see what we get. The value of our floor function is going to change when nk is equal to 1,000 and when it's equal to 10,000. This happens at 9 and 90. Calculating our floor functions on these different intervals, we see already that we have more values of 4. And f of 110 is 301, so we just missed it. Let's try n equals 109, and we'll calculate our cutoffs. Where it changes to 1,000, k is going to be less than or equal to 9, and then at 10,000. K is less than or equal to 91. We can see by inspection that we're going to change a 4 into a 3 and lose 1 point. So f of 109 is equal to 300, and that's our maximum value for n. If you'd like me to solve any other math contest problems, please leave them in the comments.